Hi guys, welcome to part 4 in this Bitcoin Cash wallet tutorial. In this video, we're going to be very briefly giving an overview over public key cryptography in terms of how it relates to the Bitcoin Cash network, and we're going to be implementing the heart of our wallet. By the end of this video, we're going to have a full real wallet which is capable of creating a deposit address where you can send money to add funds to your wallet. So that's it for the intro, and let's jump right into it. So first of all, I'm gonna see where we left off on the previous part. This is essentially the way that index.js file was looking by the end of part 3, and this is wallet.js, which, as you can see right now, is mostly just an empty shell of what our wallet is gonna be. So before actually starting to write any real code, I wanted to very briefly show you guys how public key cryptography works on a very high level and how it relates to Bitcoin Cash. So the most important thing that we're gonna be using from public key cryptography is the concept of creating a pair of keys, what is called a private and a public key. The reason why this is important in the Bitcoin and Bitcoin Cash networks is because the easiest form in which you can send money to someone is you essentially create a transaction that sends money or creates an output of a certain amount of satoshis addressed at a certain public key. For example, if Alice has a public key and a private key, I can send money to Alice by creating a transaction that sends, for example, 10,000 satoshis to the public key of Alice. At a later time, when Alice actually wants to spend the money that you sent to her, she will need to provide proof that she owns the private key, which is related to the public key that received the money. There is some very interesting mathematics going on here behind scenes. I seriously recommend that you look into it if you find all of these interesting. But the real important part of what public key cryptography provides to us as programmers is this ability to create a pair of keys, a public key and a private key, whereby anyone can have the public key, and Alice is the only person who owns the private key related to that public key. And at a later time, anyone can prove that a given message was actually created by Alice or whoever really owns the private key. This is important because in Bitcoin, like I said, funds are essentially sent by creating an output which has a public key attached to it, and then whoever owns those funds can only spend them by creating a transaction which essentially proves ownership of those funds. And the way that they do that is by creating what's called a digital signature with their private keys, which is a very interesting way. There's a lot of very interesting mathematics going on back there, which means that someone can actually prove that they own a private key related to a given public key without actually ever showing their private key to anyone. This whole set of algorithms are called digital signature algorithms. I also recommend that you look into this if you're interested. In this specific case, if we look at the graph here on the right, the way this would work, for example, the hello Bob message that we have here on the left can get signed with Alice's private key, and then the combination of the original message together with a signature can be forwarded to Bob, where he can verify with Alice's public key that the hello Bob message was really created by Alice. In the case of Bitcoin Cash, this the message itself is a transaction, which essentially says I want to spend a certain amount of money. the way that this works in the Bitcoin Cash network is this hello Bob message, instead of just being hello Bob, would be something like, I want to spend a particular output which already exists in the network. Then Alice would sign this transaction with her private key, and then Bob in this example is actually the miner that is verifying this transaction. And the way that the miner verifies it is by getting Alice's public key and making sure that whoever created this transaction, which is spending Alice's money, must have had Alice's private key. So this is all I'm going to say for now. Like I said, I seriously recommend that you look into this a bit deeper if you haven't already. But this is all we need to start writing some code. So in our example, the first thing that we actually need to do is create a private key, which is going to be the one that essentially proves ownership of the funds which are sent to our wallet. So the first thing I'm going to do is I'm going to add a private key here, which is going to get created during construction time. For this, I'm going to use Bitcore, which already provides all this functionality. When I call the private key constructor from Bitcore without any arguments, it's actually going to create a completely random private key. And once we have the private key here created in our wallet object, the getPrivateKey function, which is defined here at the bottom, can already be implemented in full. We could just do return this dot underscore private key. However, the private key itself on a low level, it's actually just an array of bytes. So whenever people are somehow storing private keys in textual form, there is this special format which was created for this very purpose, which is called the wallet import format, which given a private key just generates a string representation of that private key, which is easier to store and to write down. So this is also implemented in Bitcore. You can do private key .to WIF, which means wallet import format. If we do this and just refresh the page, we should be able to see now, when I click on the show and hide button, we are already seeing a very real private key in wallet import form. This format actually is not just a private key, but it also adds a small prefix which determines in which network this private key is meant to be used, and it also adds a checksum which makes sure that we haven't accidentally mistyped some character or something like that. So now we already have a fully very real private key that we can show and hide on our UI. Now the next part that we can do is, from this private key we can derive its public key, and from a public key then you can derive what is called an address. So a couple minutes back I said that when you want to send money to someone on the Bitcoin Cash network, you actually provide their public key. This is not true anymore. It used to be like that in the very beginning. There was a basic improvement which was done upon it, which is, instead of sending money to a given public key, what you do is you create an output to a hash of a public key. That hash of a public key, together with a small bits of information of metadata, is what is actually known as an address. So whenever you copy paste an address, the string that you're copy pasting is actually a hash of a public key together with some metadata. So what that means is, if we actually want to get the deposit address for our wallet, we just need to get it from the private key. So we could get the public key from the private key, and then from the public key we could get the address, which internally just boils down to actually hashing the public key. and then again, this is just a Bitcore address object, so we actually want to transform this into a string. So let's see what happens when I refresh the page. So now this is the first time that we're getting a real Bitcoin Cash address on our wallet. We could already send funds to this address and they would be accredited on our wallet. However, we have a problem right now, which is see what happens when I refresh the page. In fact, you might already be seeing that the private key that is being displayed on the button is actually different to the one that we had before. I'm going to refresh the page and take a look at the private key. As you can see, once again, it has changed. This is because every time that the wallet module is being instantiated, we're creating a new random private key. That means that whenever we refresh the page, the old private key, which was only living in memory, is actually lost forever. So we don't really want to send money there, because otherwise, whenever we refresh the page, then we've lost access to our funds. So the way we're gonna improve upon this is we're gonna give the wallet a way of either creating a new random wallet if you don't have anyone, or just restoring an existing private key if we already have one. So I'm gonna add an argument here to the wallet module, which is called private key. Now this private key that I have here is actually gonna be a private key in wallet import format, exactly the same format that is produced by the getPrivateKey function. So now I'm just going to ask if the private key that I'm getting as an argument hasn't been defined. That means that I don't have any private key yet and I need to create a new random one. Otherwise, the private key that we're going to be using is just again, Bitcore has a static function on the private key module, which, given a private key in wallet import format, it just creates a private key object. So I'm actually gonna make this the other way around. So if the private key that we received as an argument is not undefined, that means that we have actually received a private key. So we're gonna use Bitcore's from wallet import format function to actually reconstruct the original private key. Otherwise, no private key exists yet, and we're just gonna create a new random one. Now, what I want to show with this, since we're actually instantiated without any arguments, if I refresh the page, I'm going to lose the private keys the same as we were losing them before. It's still changing, but the difference is that now we can actually provide a private key as an argument. And now every time I refresh the page, we always have the same private key. Now, before actually to move forward, we need some way of actually storing our private key, because the first time we ran the wallet itself, we don't have anyone, we create one randomly, but then when we refresh the page, we actually want to provide the pre-existing wallet somehow to our module. So for that, we're going to use what is called local storage, which is a form of web storage which is implemented across most browsers. It allows you to actually store, it allows any website to store tiny pieces of data in a way that such that only the same website can access it at a later time, even if you close the browser and then reopen it in the future. This is done in a safe way, in the sense that no website should ever be able to access another website's local storage. So what we're going to do in this case is if the wallet was already that doesn't exist yet, we create one randomly and we store it in local storage. Otherwise, if we already find a wallet in local storage, that means we've created it at a previous time and we just want to restore the existing one. So I'm going to go ahead and start coding that part now. So first of all, I'm going to create a constant which is going to be storage key private key, which is the way you store things in local storage. It is essentially just a key value, a string key value dictionary essentially. So anything that you store in local storage needs to be indexed by a string key. So in this case, since we're just going to store a single piece of data, I'm going to use this key here. That the only important thing is that it never collides with any other part of your application. In this case, what we're going to do is we're going to check if there exists an item in local storage with this given key. That means that it has, actually I'm going to do it the other way around. If there isn't any item in our local storage defined under this key, that means that we've never created a wallet yet and we want to create a brand new random wallet. So for this, we're going to create a wallet without any arguments, the same way that we were doing it before. And otherwise, the wallet that we're going to create is actually the wallet that we had actually stored there. So for that reason, we need to get the item again, which is the actual private key. And there's one thing here which is missing, which is whenever we create a random wallet, we also wanna make sure that we actually store it in the local storage. So right after creating the new random wallet, we're gonna set that item into the storage, which is going to be just the private key of the wallet. So right now, if I refresh the page and everything is right, we should be always getting the same wallet. So L2Q7K, if I refresh the page, L2Q7K, and that's it. Our wallet has been created and is now stored in local storage. In fact, if I look into local storage, I can see how just a second, I have some old things there. I'm going to clear the local storage. I'm going to refresh the page. Now we have a new wallet because I just cleared local storage. Now we can look into the local storage and see that we actually have a key, BCH wallet 1A private key, which is storing exactly the same private key that we're displaying in the UI. So now everything is in place to actually implement the import function, because importing a private key just means rewriting the one that exists in local storage. That's pretty much all that we need to do. We also need to refresh the page to make sure that the deposit address and later on the balance get updated. So we're going to do all that right here. The way that is going to work is whenever somebody submits the import form, we're actually just going to do local storage dot set item storage private key with the new value, and right after this we're also going to reset the value to an empty string to make sure that we don't actually leave the private key hanging there in the UI. And last, we're going to actually refresh the page by reloading it. Now just a minor improvement here. When people copy paste strings many times, we're left with tiny amounts of white space either at the beginning or the end of the string. So instead of just sending the value here, which would cause a problem when we're trying to deserialize it, I'm just gonna create a private key value, which is just the same value that we had before, but I'm also gonna trim it, which this function trim just removes any white space from the beginning or the end of the string. So now if I refresh the page, here we have our private key. I'm gonna put it in the import function. You can see it's the same private key. In fact, we already have some white space here. Now I'm gonna click on import. I'm gonna refresh the page, and here we go. That's the same private key that we had before. That makes sense. Now actually I can clear the local storage again. I can refresh the page. Now you're gonna see that our private key has actually changed, but I can restore the old private key by clicking on import. Now it's the same private key as before, and at the same time you can see that the deposit address, which is derived from the private key, is always the same for a given private key. So essentially now we have a wallet which has the inner the kind of the heart of our wallet is now complete, because we already have a private key which is being persisted into local storage, and we're already generating a deposit address which can be sent to which can be used to send real money, and our money will not be lost because we've persisted our private key. Now we can't really see any balance that we generate by sending money yet, but that is left for part number 5. So thanks for watching, and see you on part number 5.